what he can jump at the middle of the season, and we know his goal. Okay, so the trickiest thing about this problem is that you have to do two conversions, right? So I know that my answer is going to be in meters, but the coach is comparing it to feet. So first thing I'm going to do is convert his current height to feet. So I'm going to have 1 meter equals this 3.281 feet. So 2 meters will equal how many feet? So when I multiply those, 2 times 3.281, what's that going to give me? Those of you that converted that to feet, what did you get there?
I got 6.556.
Yep. And this is his starting height. Remember, we've talked at length about labeling things, so we keep track. That's how high he can jump at the beginning of the season.
Goodness gracious.
He increases it by 8%. So I'm going to use my calculator, 8%. The word of pops up, 6.562. And I get 0.52496, which I'm eventually going to round. Because he's increased in the height, what am I going to do with these two values? Add them. So his mid-season height, I'm going to round to 7.09 feet. It's pretty high. Remember, his goal is 7.5 feet. So how much is he away from his goal? So I'm going to take the 7.50 goal minus 7.09 current, and I'm going to get 0.41 feet, which is awesome, except what are they asking for my answer in? Meters. So I have to take this and make another proportion. I know that 1 meter equals 3.281 feet. So how many meters would be 0.41 feet? .281 x equals 0.41. And when I divide to get rid of that coefficient, you get about 0.12 meters. So this is how much further he has to, how much higher he has to jump to meet his goal. So the solution is 0.12 meters. How many people got to the number of feet he had left to go? Because that's most of the battle, right? Mason, are you getting all this written down? Okay. So if you had gotten here, you wouldn't get all the points, but you'd get most of them. The only thing you didn't do was convert them to meters, right? As long as you're labeling and I can see your process, then you're going to get some points for doing something correct, right? Let's move on to question 2. We have Kelsey, who's a swimmer. Anybody in here a swimmer? Anybody swim on a swim team?
My mom swims.
Your mom does? It's a good sport.
Oh, not for a sport.
Just in general? Okay. So this is an event where the swimmers do each stroke, a couple lengths of each stroke. We're going to try to find out how long in minutes it took her to do the whole race. I'm going to keep everything in seconds and convert last. If you wanted to convert to minutes first, that's up to you. We know her butterfly time. Backstroke is 90% of the breaststroke leg. So if you didn't read that carefully and you took 90% of the butterfly portion, then you might not have the right time. I'm going to use my calculator. 90% of 72 seconds. And I'm going to get 64.8 seconds. And that's for backstroke. We know this time, we don't have to do anything there. Freestyle is 85% of the new backstroke time that I had. So now I'm going to do 85% of 64.8 seconds. And I'm going to get 55.08 seconds. So now I know all 4 strokes times. I'm going to add them up. 45 plus 64.8 plus 72.0 plus 55.08. I always fill in the missing spaces of the zeros that I need. And I end up with 236.88 seconds. But I'm not done. What do I have to do?
I know.
Xavier?
So you have to convert it into minutes.
Correct.
So you do 1/60 for 1 minute, and seconds, and then you put the 236 on the bottom, and 60x equals 236.88, and then you divide by 60,
Mm-hmm.
and I have the answer for
60x equals 236.88 when I do my cross multiplying for the proportions. So what did you get? How many minutes does that equal?
4.
Well, we're going to keep it as 2 decimal places
Oh.
because it says the nearest hundredth.
3.9.
Uh-huh. So the solution is 3.95 minutes.
The reason I didn't do the 0.95 is because I thought like having 95 seconds.
Oh,
I just got confused.
that's okay. Yeah, so it'd probably be right about 58 seconds or something because it's 95 minutes. You can go ahead. Yeah. Innocent? Not right now. Wait till Mason gets back, please. Okay. The last section is the fair game review. Can somebody remind me what I'm doing with these square root signs? What am I doing there? Silas?
Don't you add 1 plus 2?
No. First of all, I will have the pink paper up there during the quiz where you can see all the perfect squares. You guys know what I'm talking about? That pink paper. I'll have that there. Square root of 72 is right between 8 and 9, so that's going to be 8.5. For this one, I would take the square root of 51, which is close to 7, and add 2. So that's going to be where B shows up. And then this is like saying about 10 minus 3, which would be 7. So that's where C shows up. Right? So you estimate the closest half integer for those. Okay, you guys did pretty good on the last quiz with those. And then down here we have exponents. We have negative exponents. I know a couple people looked it up. What do we do when our exponent is negative? What do we do, Silas?
Turn it into a fraction.
You turn it into a fraction, and then the exponent is now positive. This is like saying 1 and then 2 times 2 times 2 times 2. So you would get 1 over 16. So is this equivalent to this?
Yes.
Sure is. How about here? What do I do with this 3 and this negative 7? They have the same base. So I'm going to do what, Alexia? Add them. And I'm going to get 2 to the negative 4. Where else do you see that? It's the same thing as the first one. Great. And then what does 1 over 8 squared simplify to? 1 over what?
1 over 16.
64.
Oh.
So that's a no. So only these two. Remember, this is like 8 times 8. Okay? If you didn't already write parent signature at the top of the study guide, please write parent signature. Let me look. Hold on. Parent signature there. So we have 4 points for problem 1, 4 points for problem 2. So that's 8, 9, 10, 11 points. Please make sure you take your binders home, right? So you can glance over these things before tomorrow.